This is a recording of lesson 4.1, part of the Math 020 pre-algebra course at St. Louis Community College, recorded by Dr. Victoria Shearing. In this lesson, lesson 4.1 is titled Introduction to Fractions and Mixed Numbers. In this lesson, we will cover three objectives. We will review fractions and mixed numbers. We will then convert between fractions and mixed numbers and between mixed numbers and fractions. And we will review and practice creating equivalent fractions. So let's go ahead and start with our first objective, understanding fractions and mixed numbers. In this course so far, we've talked about whole numbers and we've talked about integers. Now we are starting on the new set of numbers, which are called fractions. Fractions, unlike whole numbers, represent part of the whole. In each fraction, you have two parts. The first one is the numerator, which would be the top part of the fraction. As they're written, then you have the fraction bar, and then you would have the denominator on the bottom. So unlike whole numbers or integers, fractions always are written with the fraction bar, and they have those two parts. The denominator will represent how many parts the whole has been divided into. Okay, so the denominator, again, represents how many parts make a whole. Will make a whole. So in this case, we have 7 parts. So we had some kind of a whole number or a whole entity, divided that into 7 parts. That's the denominator. The numerator is what part of the whole that we are using. Okay, so what part of the whole is being used. Right, so those are the fractions. We also, as it is right now, we're looking at the proper fraction because we have the numerator less than denominator. Okay, again, numerator is smaller than denominator. Okay, so let's go ahead and visually imagine our fractions. And then from these pictures, we will need to use a fraction to represent the shaded region of each figure. So each figure is going to be divided into parts. So first we need to find the total number of parts that each figure is divided into. So the first square, we have 9 smaller squares. So that is going to be our denominator. Okay. So this first figure is divided into 9 total parts. So, excuse me. That means we're going to put it over 9. Okay, and then we only need to use the shaded region of each figure. So we have shaded 1, 2, 3, 4, 5 out of 9 little squares. So this fraction is 5 over 9. Okay, moving on to part B. Here we have the space between 0 and 1. That space has been divided into 5 small parts. So that means our whole between 0 and 1 has been divided into 5. Okay, so those 5 small parts would make a whole, but we're only using 3 out of those 5 parts. So 1, 2, 3. So 3 is the part that we're actually using. Okay, and the last one looks like the gas gauge. We have the empty to full, and we are, so to go from empty to full to whole, we have 4 total parts. So our denominator is 4, and because right now our gauge is on a 3, so we're only using 3, 1, 2, 3 out of those 4, so that is our numerator. 3 out of 4. Okay, now we're going to switch around, and in the next example, we're going to shade the part of the whole that's represented by the given fraction. Okay, so here in part A, we have a rectangle that is divided into 5 parts. That's what makes it whole, 5 parts. But we only need to use 4 out of those 5. So we're going to shade the region that has those 4. Okay, 1, 2, 3, and 4 out of those 5. Okay, and on the next one, we only need to use half of the circle, so we would shade half of the circle, even though the circle is broken into 4 parts. So 2 out of 4, or 1/2, is going to be our fraction. All right. So hopefully that that's been pretty easy. So the next part is we're going to talk about improper fraction and mixed numbers. So far, all the fractions that we have seen, just make sure that fits into the box. So far, all the fractions that we have seen have been proper fractions because we had the numerator less than denominator. So that's the definition of the proper fraction. If you have a fraction in the form of a over b, the proper fraction will be where a is less than b. For example, we have 3 over 5. Okay, so your top is less than bottom. You have 1/2. Or you have 7 over 12. All of these are improper fractions because your a is less than b. Now we're going to, so anything else is improper fraction, meaning that your a is either greater than b or equals to b. So anything other than where your top is less than bottom is called improper fraction. So the examples of improper fraction would be, let's go ahead and flip our proper fractions. 5 over 3, 2 over 1, 12 over 7, and we're going to add one more because they could be equal to each other. Let's say 4 over 4. Okay? Because sometimes we can have a fraction where the numerator equals the denominator. So all of those are improper fractions. All right. And then we have the concept of the mixed number. So sometimes what we have is we have a whole number followed by a fraction part. We call that a mixed number, a combination of a whole number and a fraction. Okay, so a mixed number consists of a whole number, a, and a fraction, b over c, where c is not equal 0 because we can't divide by 0. So we always, every time we do the fraction, we always have to specify that the denominator is not equal 0. Okay? It is written as a for the whole part, b over c. So some of the examples of mixed numbers would be 2 and 1/2, 9 and 3/4, 12 and 5 over 7. So all of these are mixed numbers, and I'm sure you can come up with a couple of examples on your own, how they look like. All right. So the first skill that we're going to practice on is how to write improper fraction and mixed number that represented in that represents the shaded region. Okay. So in part A, what we have is we have 3 separate triangles, and each one of them is divided in 2 parts. So that means that in each triangle, 2 parts make a whole. So that means our denominator is 2. because each one of these triangles, so I'm looking at the first one, is divided in two, and that's one separate triangle. I have the second one divided in two, and I have the third one divided in two, but I'm only using one out of those two parts. Okay, so let's start with improper fraction. Okay, for improper fraction, you would start with the denominator. So the denominator is 2 because each separate triangle was divided in 2. And then let's count how many shaded parts we actually have. And I have 1, 2, 3, 4, and 5. Okay, and the sixth one is not shaded, so I cannot use it. So it's going to be 1, 2, 3, 4, 5. Okay, 5 over 2. Okay. Now let's go ahead and talk about the mixed number. Mixed number is going to have a whole part and a fraction part. So what I do have is I have two whole triangles here. I have two whole triangles and I have a half a triangle. All right. So I am going to write my two whole triangles and 1/2 of the triangle, and that's my mixed number. So come to part B. First, we're going to decide what makes it a whole. I have four squares. I have four squares, each one of them divided into 4 parts. So 4 parts of each square makes a whole square, whole big square. Okay, so the denominator means the denominator is 4. Okay, so then I'm going to count how many colored squares I have. I have 4, 8, 12, and 13. So for improper fraction, I have 13 over 4. And for mixed number, I clearly can see that I have 3 completely colored squares. So I have a 3 for the whole number. Okay, and then I only have 1 out of 4 colored squares, a 1 colored square out of 4 on the last of the squares. So I have 1 out of 4. So 3 1/4 is your mixed number. Okay, and then here we come to the last example. Now, my nail here protruding beyond 1 inch, so I am going to take a look at the tick marks and see, because 1 inch is one whole number, and I'm going to get the denominator from those tick marks first. So I see that there are divided into 8 tick marks between 0 to 1, so that means my denominator is 8. And then I need to go all the way. So imagine that this is your colored part right here, all the way here. All right. So let's go ahead and count all those little tick marks. So I have 8, 9, 10, 11, 12, and 13. So I have 13 out of 8. So 13 colored tick marks, and the denominator is 8. 8 makes a whole. Remember, you have to have an improper fraction. Your top needs to be greater or equal to the bottom. Okay, so for the next one, okay, for mixed number, I am going to get my whole. I have 1 inch, that's my one whole. And then on the second inch, I'm only using a part of that second inch. So, and I'm only using 5 out of 8 there. So that means I have 1 and 5 out of 8. Notice that the denominator does not change between your improper fraction and mixed number. So we had 5 over 2 and 2 1/2. We had 13 over 4 and we have 3 1/4. And we had 13 over 8 and we have 1 and 5/8. Okay. So the denominator doesn't change. It's how you represent the number changes. All right, so now we're ready to have a formalized rule how to convert between the two, because as you have seen, the improper fraction and a mixed number represent exactly the same concept. In each example, there was exactly the same number of colored parts. They're just written differently. One as a improper fraction 1 as a mixed number, but it represents the same number. Okay, so to convert an improper fraction to a mixed number, we have 3 steps. I am going to work out an example as I read you those steps, so it's easier to understand. We're going to work on number, let me do 17 over 5. Okay, so that's going to be our fraction. So I'm going to use that example, 17 over 5. Okay, so let's see my first step. To convert improper fraction to a mixed number, I need to start by dividing denominator into the numerator. So my first step, I'm going to do 17 divided by 5. And I'm going to get 5 goes into 17 3 times. And I have my remainder 2. Okay. 3, remainder 2. Okay. So let's look at the second step. Identify the quotient, remainder, and denominator. All right, so let's go ahead and label everything that we have. The 3 is the quotient, which is the result of the division. The remainder is 2, and our denominator is what we were dividing by, denominator. So those are the 3 parts, okay? So now we're going to write the mixed number as quotient first, and then remainder and denominator, all right? So we're going to start with our quotient, which is 3. So this is your step 3. 3. Then I'm going to grab my remainder, 2 over 5. So that's how you do the converting improper fraction to a mixed number. In short, do your division, and instead of writing the remainder, leave it as part of the fraction. Notice how we had the denominator 5. We're still keeping denominator 5. That doesn't change. All we're doing is extracting the whole part out of this improper fraction. And the whole part was 3 times 5, which is 15. So we took 15 out, and we left 2 in here. All right, so to convert back, we do the opposite, okay? To convert a mixed number to improper fraction, we're going to go and work backwards. So if we were dividing to convert improper fraction to mixed number, now we're going to be multiplying, okay? So let's go ahead and do the same example that we just did using the same numbers, because we already know the answer, 3 and 2 over 5. So that's what we're going to use. So 3 and 2 over 5, so that's our mixed number. Multiply the whole number by the denominator. So step 1, I'm going to do 3 times 5, which gives me 15. Okay. Step number 2 is add the numerator to the product found in step 1. So what I have is, I have 2 plus 15 is 17. And step number 3, write the final sum over the original denominator. So the denominator is still 5, right? But now the new top number is 17 because I multiplied the whole part by the denominator, and then I added that into the numerator. Okay, so that's how you get 17 over 5. All right, so let's go ahead and practice on these. Convert each mixed number into improper fraction. And convert each improper fraction to a mixed number. So we'll do each one. So mixed number to improper fraction, we are using multiplication. And then the other one we're going to be dividing. All right, so we have -3 and 3/4. So we just need to multiply -3 times 4 equals -12. So -12 plus 3 gives you -9. That's our new So that means negative 9 is the new, negative 3